Right, we're going to factorise some quadratic equations now, and that's on page 132 to 133, section 12.1, and starting at grade B and going upwards. Now, the thing is with quadratics is that some of these little things require two brackets to factorise them. So look at this one. I've got a squared plus 9a plus 20. So I know you've multiplied out double brackets before, and the question is, what was this before we took it out of its brackets? So we've got to think backwards. So a times a would definitely make a squared. Happy with that? A times a squared. Now, how do you make 20? Well, 1 times 20. The 1 and 20 won't result in 9 a's. 2 and 10 won't do it. How about 5 and 4? Yep, 5 and 4 is the way to go. And it's plus 4 and plus 5. Let me just show you the thinking behind that. A times a, you know, is going to be a squared, so that's happy. A times 5 is going to be plus 5a. 4 times a is going to be plus another 4a's, and 4 times 5 is going to be 20. Altogether we've got a squared plus 9a's plus 20 at the end, and that works fine. Now, I won't be doing this all the time. In fact, I won't do it again at all. Thing is, in order to test yourself to see if you got it factorized completely and correctly, you need to multiply out just to see if you get back to the original question. So that's been factorized. That's grade B. Put a little b there. That's what it is. Miss out a couple. I've got another one. D squared minus 7d plus 12. And now this is question 4. And let's have a look. Well, in order to split off d squared, you want a d times a d, don't you? Now, look at the 12. I want to end up with 12. I need to multiply two numbers that make 12, which when I add will make minus 7. So 1 times 12, no good, makes 13 or 11. Let's have a look. What else have we got? 2 times 6, that'll give me an 8 or a 4 difference, no good. 4 and 3 is lovely, because 4 and 3 will give me a 7. Now be very careful. I want to end up with minus 7d, so I want a minus 4 and a minus 3. That will give me minus 7d's. Minus 4 times minus 3 is plus 12. Let me just prove to you without having to write it that I'll get minus 7d's. Well, d times d, d squared. D times minus 3, minus 3d. Minus 4 times d, another minus 4d's. That gives us minus 7d's altogether. So I know this is correct. Skip a few more now. I've got n squared. This is question 8. Minus n minus 20. Now all these are little minuses. Again, n times n is n squared. Now in front of the n you should know there's a minus 1 there. If it was minus 2 it would say minus 2. If there was nothing there, n wouldn't even exist. So we're trying to get a difference of 1 somehow. So 1 times 20 is no good, difference of 19. 5 fours are brilliant. I'll tell you why, because 5 and 4 will give me a minus 1. Now be careful, one of these has to be positive, the other one has to be negative, and it has to be the right one. Well, I want to end up with minus 1n, so I want the 5 to be bigger than my 4. So it's minus 5 and plus 4. Quick check, n times n, n squared, n times minus 5, minus 5n. I will write that for you. And 4 times n is plus 4n. And that's why you got minus n total. And 4 times 5 is 20, but it's negative. Is that alright? So I'll leave that there. Let me go for question 13. No, question 14. Let's just do 14. I've got x squared plus 10x minus 24. Factorise. That's simple. X times x. How do you make 24 and still end up adding up to make 10? 2 and 12, it's got to be right, isn't it? Because 2 and 12 will give me a 10. I want to make 10 to be positive, so the 12 needs to be positive and the 2 negative. Let's check this out. Minus 2 plus 12 is plus 10. Minus 2 times 12 is minus 24. I know that's right as well. Let's just do number 18. And we'll do a couple more, and then we'll finish the section B part of this and do some more dangerous ones. So question 18, I've got k squared minus 13k, oh, don't like them, plus 22. factorising that, 2 brackets, k followed by k makes k squared. How do you make 22? 1 times 22, 2 times 11. Yeah, I can see 2 and 11 will make a 13 quite nicely. You see, after you do about 20 of these things, you begin to see them as second nature, and you know, 2 11s make 22, 2 plus 11, 13. But I want a double minus, because minus 2 times minus 11 will give me plus 22, minus 2k and minus 11k will give me minus 13k. So I'm very confident that's correct. All these of course are equal, because all I've done is factorised the original expression and their equivalents. That one too is equivalent. Space for one more perhaps? Do it here. Y squared plus 2y minus 63. Absolutely terrifying, because 63 is a big number, 2 is a titchy number, and I'm worried. Trouble is 7 9s are 63, and 7 and 9 would give me a difference of 2. Put it wherever you like, put the 9 there if you want and the 7 there, but the 2 is positive, therefore 9's got to be bigger than 7, so I'll have plus 9 minus 7 there. There you go, 9x's positive, and y times minus 7 minus 7x's. So 9y's take away 7y's, 2y's which are positive. 9 7s are 63, but it's negative because of the minus there. And I'm fully confident that's correct. Right, what's all this about? There's things like this, which I think I'll give them their own page. There's things like this, which are called the difference of two squares. Now, A is a square number or letter, and B is a square number or letter. Now, if you were to factorise that little thing, you'd get this: A plus B multiplied by A minus B. Now, trust me on this one, if you were to multiply this all out, the AB term would just cancel out completely. Okay, I'll do it for you. You twist my arm. A times A is A squared. A times B is AB, but it's negative. B times A is plus AB, and B times B is B squared, but it's negative. What have we got? The minus AB plus AB has gone bye-byes, and therefore we're left with A squared minus B squared, as per the original question. Alright, so that's how and why it works. This next one is incredible. Well, I know how it goes anyway. So 4c squared minus 25d squared. Now look, it's very unkind for them to land this on you because it's only the second one of its kind. But look, 4 is a square number and 25 is a square number. So here's the next step. I've got 2 squared times c squared minus 5 squared multiplied by d squared. Alright, I'm doing this all big. Now I've got two parts, two terms, which I can split up using the difference of two square rule. Now look, two giant brackets, 2c there, 2c there, 5d there, 5d there. I can put a minus on one and a plus on the other. Now this will definitely work out to 4c squared minus 25d squared. Well, let's just do it, shall we, since it's one of its kind. 2c times 2c, 4c squared. Change colour. 2c times 5d is going to be plus 10 cd's. Change colour again. 5d times 2c is another 10 cd's, but it's negative. And finally, I need another colour. Let's go white. It should stand out. Yeah, it does beautifully. Minus 5d times plus 5d will be negative 25d's. And as you can see, all these cd's disappear. And I'm left with the original question, which was 4c squared minus 25d's. Oh, squared. Sorry, I beg its pardon. Oh, forgot about the square there. Just put it back in quickly. Alright, that's that. That's very colourful and very beautiful. And I think I want to do a couple of these on the side. It says, use your knowledge of the difference of two squares to work this out. Alright, so let's go yellow then. I've got 31 square minus 30 square. Please don't work out 31 times 31. It's not worth the trouble. But you know it's the difference of two squares. So it's 31 minus 30 multiplied by 31 plus 30. Right, difference of two squares. Works for letters, certainly works for numbers. Right, 31 take away 30 is 1. 31 plus 30 is 61. 1 times 61, 61. Thank you, very nice. Now I think I'll do this one as well. It says 57 squared minus 43 squared. Well, that's going to be 57 plus 43 multiplied by 57 minus 43. Hope I've got space there. I don't start crashing into my little picture. Right, I've got there 90, 100. Great. So I've got 100 times 57 take away 43. That's going to give me 14. And therefore, altogether, 100 times 14, 1,400. And that equals that, which equals that, which equals that, which makes me happy. So therefore, I'm now going to stop and think about doing something a little harder than grade B.